It is highly possible that El Niño will break a record and cause significant changes to weather patterns across the world. The arrival of El Niño is anticipated to have significant ramifications on global weather patterns, including but not limited to droughts and floods. Additionally, there is the possibility of breaking records for the hottest year due to its presence. The world witnessed an exceptionally potent El Niño event 7 years ago, which had a cascade of devastating effects on global weather systems. The Pacific Ocean's disturbance resulted in a severe drought in Indonesia, leading to intense wildfires, and in parts of the Horn of Africa, heavy rainfall caused flooding in villages and farmlands. Furthermore, this event contributed to 2016 becoming the hottest year ever recorded on the planet. The reappearance of El Niño is imminent. There is a fair chance that this instance will be equally robust, creating unease about the emergence of severe weather patterns in the upcoming months. It is highly probable that a potent El Niño will result in another global temperature record. El Niño is a naturally occurring climate cycle known as El Niño Southern Oscillation. Its main identifying feature is a strip of ocean water in the tropical Pacific Ocean that is warmer than usual, stretching across the eastern and central regions. Its opposite state, La Niña, is characterized by colder than normal water in the same areas. The ocean shifts between these two states every 2 to 7 years, although for the past 3 years, 3 consecutive La Niñas were seen, which is unusual. During these events, changes occur in the ocean's surface temperatures, leading to a shift in heat release into the atmosphere above. This change can influence atmospheric circulation patterns and trigger a chain reaction that can cause significant alterations in global weather patterns. The timing and extent to which regions will experience the aforementioned changes are dependent upon their location. Generally, locations closer to the tropical Pacific will be subjected to more immediate and probable effects. Additionally, the impacts of El Niño are typically more pronounced during the winter of the Northern Hemisphere when the phenomenon reaches its peak strength. Michel Leheureux, a forecaster at the National Oceanic and Atmospheric Administration's Climate Prediction Center, explains that the greater the strength of El Niño, the more certain we can be about its impacts. The current El Niño is predicted by NOAA to have a 56% chance of being strong. The benchmark for measuring El Niño is when temperatures in a specific part of the tropical Pacific are at least 0.5 degrees Celsius or 0.9 degrees Fahrenheit above average. A strong El Niño is defined as temperatures that are 1.5 degrees C or 2.7 degrees F above average. According to Leheureux, it is important to note that even if this El Niño develops into a strong or extremely strong event, it is not a surefire guarantee that any specific weather changes will result. Southern California, for example, often experiences rainy weather during a strong El Niño, but this did not occur during the 2016 episode. This is because El Niño is not the sole factor at play. Other natural climate cycles and regional factors also have an impact. The alterations in global weather patterns caused by El Niño are connected to 2 primary air circulation systems, the Walker and Hadley circulations. These are essentially large vertical cycles of air, with the former running along the equator and the latter running perpendicular to it. Typically, the waters of the tropical Pacific Ocean are warmer in the west and cooler in the east. These warm waters foster convective activity, where hot, moisture-rich air rises and creates rainfall until it reaches the tropopause, where the lower layer of the atmosphere, known as the troposphere, intersects with the stratosphere. The air then moves from west to east, descends over the eastern Pacific, and then flows from east to west along the Earth's surface. However, during an El Niño, everything shifts towards the east. Air rises over the eastern Pacific and descends over Southeast Asia. This change results in drier weather in Southeast Asia, which can lead to severe droughts and food shortages, as well as contributing to the spread of wildfires. During an El Niño, the Walker circulation shifts and causes the descent of air to northern South America and the Caribbean. This subsidence acts as a barrier to hurricane activity in the Atlantic Ocean because it suppresses the convection that propels such storms. The alterations in circulation patterns also increase the occurrence of wind shear, which can impede the development of storms. However, this year, the impact of these factors will be counterbalanced by the unprecedented scorching temperatures in the Atlantic, which will provide optimal conditions for the generation of storms. With these opposing forces at play, the National Oceanic and Atmospheric Administration, NOAA, has forecasted a season that is almost average, with a possibility of 12 to 17 named storms, out of which 5 to 9 may reach hurricane status. The Hadley circulation, which travels in a north-south loop on both sides of the equator, also influences US weather during an El Niño. During this time, there are changes in the circulation that cause the subtropical jet stream, a swift-moving air current that steers storm systems across the nation, to move further south during the winter months. This usually results in cooler and moister conditions in the southern United States, while the northern parts of the country and certain regions of Canada experience warmer temperatures than usual. During El Niño events, various climatic changes can occur. These changes often include warmer and drier conditions in eastern Australia, as well as certain parts of India and southern Africa. Conversely, regions such as Kenya, Somalia, and Ethiopia tend to experience an increase in precipitation, which can be a positive development after enduring prolonged droughts caused by climate change. However, excessive rainfall can lead to flooding, mudslides, and the spread of waterborne illnesses. During an El Niño event, one of the most predictable outcomes is an increase in global temperature, as the ocean discharges excessive amounts of heat into the atmosphere, which has been observed in previous El Niño years. This additional heat will amplify the effects of global warming due to human fossil fuel consumption and may lead to 2021 or 2022 being the warmest year on record, just as it did in 2016. The El Niño's influence on global temperature takes a few months to be felt. The 2016 El Niño was as strong as the one in 1998, but it was warmer by 0.5 degrees Celsius, 0.9 degrees Fahrenheit, because of the impact of global warming. Moreover, before the current El Niño was officially announced, the global average ocean temperature had already reached unprecedented levels, increasing the possibility of another record-breaking year, according to L'Heureux. "That's pretty insane," she says. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.